Hello, Assalamualaikum, and good day. So today I would like to share on how we can use Minitab 19 to analyze our gauge R and R. So example here, in this case, we have a scenario given a manufacturer installed a new measuring device and engineers want to determine how well the new system measure the nozzle. So they have selected two operators for this experiment, and every operator will be given the same 9 samples, and each sample need to be tested twice. So in this case, since in this measurement experiment it's using the same sample, so we need to analyze the result by using gauge R and R cross. If you can use nested if the measurement is measuring a unique sample. So usually nested is meant for destructive testing. So let's see how can we analyze and then how to interpret the gauge R and R graph output and draw conclusion from the result. So this is data. Okay, so the measurement result is in C4. So I will start with stat, quality tools, gauge study, and gauge study R and R cross. So parts number, this is where I need to select nozzle, operator is C2, and measurement data in diameter. And for cross, I usually use ANOVA because ANOVA estimates the variance more accurately and provide more information about interaction, whereas X bar R, it will not able to calculate the variance of the operator by part interaction. And the rest I remain as a default. So I click OK, and I will get the numeric result. This is the numeric result, and also we'll get the graphical result down here. Okay. So the numeric result, first we have a look at the first table. This is a two-way ANOVA table with interaction. So why we have a two-way? Because we have two factors in this experiment. The factors is nozzle and also operator. And if you have a look at the interaction between nozzle and operator, the p-value is more than 0.05, meaning to say it is not significant. Thus, Minitab will generate a table, this table, which is the table without interaction. And if we have a look at the p-value for nozzle and operator, we can see that only nozzle is significantly impacting on the variation from the C4 result that we have collected. Okay. All right. So if you want to know what is the percentage, okay, the percentage of variation from each source of the measurement system, you can refer to this variance components table. And if you can see, the total gauge R and R is contributing only 0.8%. So this is actually addressing the p-value more than 0.05. And mostly the variation on the C4 data is coming from the parts to part itself. Okay. And if you want to get the comparison measurement system variation to the total variation, then you need to look at this gauge evaluation. And from the percentage study variance, we can see that 8.97% of the variation of the total variation is coming from the measurement system. So how can we say, or how can we conclude from these two figures whether it is acceptable or not? Okay, so I will go back to the PowerPoint. So based on AIAG, okay, Automotive Industry Action Group 2010 4th edition, says that the percentage tolerance or percentage of study variance should be less than 30%. All right. So in our case right now we have even less than 10%, which means acceptable. And the percentage of contribution should be less than 10%. In our case, we have definitely less than 1%. So this is how we gauge. Another parameter that we can use to gauge the acceptance level of our gauge R and R is by referring toward the discrete NDC, number of distinct categories. Okay, so based on AIG, this number should be more than 5. Okay, so if we have looked at our result, so we can say that this measurement system is really acceptable. So usually, if you have a good result in these variant components, okay, you surely have a good result also in the total gauge and R in the gauge evaluation table. So if you look at the graph here, right? I will maximize the graph. Okay, there are 6 graphs output from this result. Okay, so the first graph, component of variation, basically from here, visually we know that the parts to parts is the most significant that impacting the variation in our measurement result. The R chart here is showing the repeatability. Okay, the R stands for range. It's showing the repeatability of the operator. We have operator 1 and we have operator 2. And in this case, every parts will be measured twice for every single operator. So what Minitab does, Minitab will calculate the range. The range meaning to say the maximum and the minimum value, okay, from these two measurements. So as long as the range in between this red line, so we can say that we have a good repeatability, and this is reflected with the very low bar for this component of variation when it comes to repeatability. Whereas the X bar chart by operator, this chart is basically representing the reproducibility. So for example, in this case, operator number 1 measures sample or nozzle number 1 twice. So the average of the sample number 1 is being plotted here. And the same sample measured by operator number 2. So the average is almost similar with the average that comes from operator number 1. So that is the reason why we have a very low reproducibility. Okay, the next T graph, okay, the fourth graph here, this is basically visualizing the result of every nozzle average, okay, by these two operators. So we only can see one line, but in actual there are two lines, but since we have a very good reproducibility, so we can't see the two lines because they have been overlapping each other. So the same thing in our box plot here. All right, so we can see that the average, okay, the average from the total measurement by operator 1 is almost the same as by operator number 2, and also we have a very good result in terms of how the operator interact with the nozzle. So we have two lines overlapping each other. So this is how we conclude that the measurement system is acceptable. And from this analysis also we can say that our operator really knows the standard way of dealing or using this new measurement system to measure the parts given to them. So I hope this sharing will benefit you. Thank you very much.